Good morning, class 12. Today we will continue to discuss the sums related to maxima and minima. Exercise 6.5, question number 23. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 over 27 of the volume of the sphere. Right circular cone is inscribed in a sphere of radius capital R. So OA equals to capital R. If we join OC, it is also radius of the circle, that is sphere. So OA OC equals to capital R. If we suppose radius of cone is small r and OB x. So height of cone will be r plus x. H equals to r plus x. So in triangle OBC, it will be right angle triangle. So r square equals to capital R square minus x square. Now volume of largest cone. So we have to maximize the volume of cone. So volume of cone is denoted by VC, that is volume of cone, equals to 1 by 3 pi r square h, which is equals to pi by 3. In place of small r square, we will write capital R square minus x square, and in place of h, that is height of cone, r plus x. R square minus x square will be written as r plus x, r minus x. So volume of cone is pi by 3. R plus x into r plus x will be r plus x whole square into r minus x. Now differentiating with respect to x, pi by 3 as it is, using product rule. So first function, that is r plus x whole square. Differentiation of second is, because capital R is constant, it is given. So differentiation of minus x is minus 1, plus second function r minus x, and differentiation of r plus x whole square is twice r plus x. If we solve inside the bracket taking r plus x common, we will get, after simplifying it, r plus x into r minus 3x. Now for maxima or minima, dv over dx equals to 0. So pi by 3 will come 0 upon in the denominator, that is 0. Now if r plus x equals to 0, then we will get x equals to minus r, which is not possible. And if r minus 3x equals to 0, we will get x equals to r upon 3. Now substituting the value of x in first equation, that is h equals to r plus x. So we will get h equals to, since r plus x, so r plus r by 3, which is 4r by 3. So height of cone in terms of capital R will be 4r by 3, because capital R is given in the question. Similarly, small r square equals to capital R square minus x square. Again we will put the value of x here. So r square minus r square upon 9. So small r square equals to 8r square upon 9. So these are the values of h, that is height of cone, and radius of cone in terms of capital R. We have to prove that volume of cone upon volume of sphere equals to 8 upon 27. So volume of cone is pi by 3 r square h, pi by 3 as it is, in place of r square 8r square by 9, in place of h 4r upon 3. So after solving it, it will be pi into 32 into r cube upon 81. This is volume of cone. Now volume of sphere denoted by Vs. So volume of sphere is 4 by 3 pi r cube, pi, and radius of sphere is given in the question, capital R. So it is 4 by 3 pi r cube. Now if we divide volume of cone by volume of sphere, so right hand side will be pi 32 r cube upon 81 into reciprocal of this 3 upon 4 pi r cube. If we solve, cancel each other, Vc over Vs equals to 8 upon 27, which implies that volume of cone equals to cross multiplication 8 over 27 volume of sphere. This we have to prove. But in the question it is given volume of cone is largest, that is maximum. So differentiating, finding second order derivative of volume of cone, it will be pi upon 3, again applying product rule, r plus x minus 3 plus r minus 3x, which is equals to pi by 3. If we solve, it is minus 2r minus 6x. Putting the value of x, we will get, or we can simply take minus common. So minus pi by 3, 2 also common. So r plus 3x. So you can see second order derivative is negative. So it is less than 0. So therefore volume of cone is maximum. Question number 24. show that the right circular cone of least curved surface. It means curved surface of cone is minimum and given volume has an altitude equals to root 2 times the radius of the base. So we have to prove that height of cone, that is altitude, equals to root 2 r. Now volume is given volume. So volume of cone is 1 by 3 pi r square h. So which implies that h will be equals to 3v upon pi r square. Least curved surface. So surface area of cone is pi r l, where l is slant height. Now you know the formula for slant height. L square equals to r square plus h square. So pi r, in place of L slant height we can put under root r square plus h square. Now s equals to pi r into under root r square plus h square. Since under root sign is here, squaring both the side, it is pi square r square into r square plus h square. Now if we suppose z equals to, in place of s square we can use z, and putting the value of h 3v upon pi r square. So it is pi square r square plus h square will be 9v square upon pi square r raised to the power 4. If you open the bracket and solve it, z equals to pi square r raised to the power 4 plus 9v square upon r square. Now differentiating with respect to r, dz over dr equals to 4 pi square r cube minus 9v square into 2 upon r cube. Now for maxima or minima, dz over dr equals to 0. If we put right hand side equals to 0, r raised to the power 6 equals to 9v square upon 2 pi square, or r equals to 9v square upon 2 pi square to the power 1 by 6, which can be written as, in place of 9 we can write 3 square. 3 square into 1 by 6 will be 3 raised to the power 1 by 3. V square into 1 by 6 is V raised to the power 1 by 3 upon 2 raised to the power 1 by 6 into pi raised to the power 2 by 6, that is again 1 by 3. Power raised to the power multiply. Now we had find the value of r in terms of v and pi. Similarly we have to find the value of h also, that is h equals to 3v upon pi r square. In place of r square, we can put the value of r from here. It will be 3v upon pi as it is. R square means 3 raised to the power 2 by 3, v raised to the power 2 by 3, and 2 raised to the power 1 by 3, pi raised to the power 2 by 3. If we solve common base, so h equals to 3 raised to the power 1 by 3, v raised to the power 1 by 3, 2 raised to the power 1 by 3 upon pi raised to the power 1 by 3. Now we have to find the relation between h and r. So dividing the value of h by r, we will get h upon r left hand side and right hand side like this. So h upon r equals to, in the right hand side, 2 raised to the, everything will be cancelled out. 2 raised to the power 1 by 3 and 2 raised to the power 1 by 6 will remain here. Bases are same, so if we add 1 by 3 plus 1 by 6, it will be 2 raised to the power 1 by 2. So h equals to 2 raised to the power 1 by 2 can be written as root 2 into r, which is proved. Now, since least curved surface, so second order derivative of curved surface area will give us 12 pi square r square plus 54 v square upon r raised to the power 4. So both are positive, so it means they are greater than 0. So therefore it is least, that is minimum. Today's homework is exercise 6.5, question number 23 and question number 24. You have to do only these two questions. Thank you, children.